Hello everyone and welcome back to another math video. Today we're going to be talking about the trig ratios, sine, cosine, and tangent. So similar to the problems you see up on the screen here. Just a reminder, this is the speedrun version where we go through it pretty quickly. If you want the normal version, that'll be linked in the description below. For your Ricasso Recap, you should already know how to do the Pythagorean theorem and you should know how to reduce fractions, or else have a calculator that can help you with that. If you want refreshers, there'll be videos in the description below. All right, new lesson starts now. Here we go. So here we have a right triangle. We're going to talk about the sine first, S-I-N-E. The sine of, and it's always an angle, so let's do the sine of angle B. So, the sine of angle B, sine is always the opposite side over the hypotenuse. Okay, and I've abbreviated here. Sine is always the opposite over hypotenuse. And sometimes sine is abbreviated S-I-N, sin, so sine of B. So from B, this is the opposite side because it's opposite the angle. The hypotenuse is always across from the right angle, which leaves the adjacent side. And the adjacent side, adjacent just means like side by side, so it's close to the angle B. So we said sine is the opposite over the hypotenuse, so that would be 30, the opposite side, over the hypotenuse, which is 34. This can be reduced by 2, leaving you with 15 over 17. For the cosine, let's do, I don't know, angle Q this time. Cosine of angle Q is adjacent over the hypotenuse, always the adjacent over the hypotenuse. And cosine is abbreviated COS. So the problem here, we need the hypotenuse. Okay, here's our hypotenuse. You know what, let's label stuff. We were looking from angle Q. So this is the opposite side, this is the adjacent side. We need the hypotenuse, but they don't give it to us. However, this is a right triangle, so we can use Pythagorean theorem to find a missing side. We should already know how to do that, so I'm going to show the work here, but quickly. So here is the work for the Pythagorean theorem, and we just get that the hypotenuse is 52. So now we do the adjacent over the hypotenuse for the cosine, and so the adjacent side here would be 48 over the 52. This can be reduced to 12 over 13. Final answer. Last one, tangent. Tangent, which is generally abbreviated to tan. Let's do the tangent of z here. Tangent of z. The definition for tangent is the opposite side over the adjacent side. So from z, this would be the opposite side, which we don't know. This would be the adjacent side, and this would be the hypotenuse. So again, use Pythagorean theorem. So here's a very brief showing of Pythagorean theorem. I didn't even show all the work, but we get that it's 48. So then opposite over adjacent would be 48 over 20. Which can be reduced to 24 over 10. That can be reduced again to 12 over 5. Final answer. All right, here's our cool clock for today, which means that it's time for you to practice what you just learned. Go ahead and pause the video and try these two problems on your own. And when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem here is the work. You had to do Pythagorean theorem. Should have gotten 28 over 53. And for the second problem, should have gotten 12 over 13. All right, last thing here is a way to remember all of this, opposite over hypotenuse, blah, blah, blah. So here are all of the definitions we talked about. SohCahToa is a one-word way to remember, okay, sine is opposite over hypotenuse, blah, 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 SohCahToa. And then here are some phrases. Some old horse, right, that's sine, came a-hoppin' through our alley. And my personal favorite, some old hippie caught another hippie tripping on acid. All right, that is it for today. I hope you all have a good morning, good afternoon, good evening, and good night.